Hello and welcome back to Triplicate, home of interesting electronics. I've been away for a bit and done a couple of other projects, so haven't actually done any work on the cat feeder for quite a while now. So I thought today we'd get back on it. Now at the end of the last video I'd finished the electronics for both sides and mounted the motors, the stepper motor for the other side, and put a couple of buttons in the back for setting where you want the timer to start. And I believe I'd started writing some code to run the second side, so without further ado, we'll look at that and see where I'd got to and see if we can get it working. Okay, so I've got some code here which I have modified to run two stepper motors. I know it compiles, but I haven't tried it yet, as usual. So I'll just run through it very quickly. So for each stepper motor we now have a stepper motor structure, which contains the I/O base, because they're all on 4 consecutive I/O numbers. We only need the base, the current step and the steps to go. Currently we only ever do one step at a time, but there is that facility to do more than one step, and the next step time in milliseconds. Not quite sure what both those variables are, but they'll probably all become clear. Okay, so here we declare 2 of these stepper motor structures because we've got 2 stepper motors, and this function just sets the stepper motor up and tells it to step a number of steps, with each step lasting a certain time in millis. Oh yes, the step time millis is the number of milliseconds for each step, and the step time next is the time the next step will occur, I think. Right, the motor next step function is as before, except now you tell it which stepper motor to drive. Okay, we've got a setup stepper motor, so we can set up each stepper motor, which you tell it the port base. So if we go down here, it's setting that port and +1, +2, +3, +4 as outputs to drive the stepper motor. Okay, so now setup sets up both stepper motors, one starting at output port 0 and the other starting at output port 4. And finally, into our loop function, we now have 2 tick times. The idea is that so whatever's supplying the power isn't hit for the current to drive both stepper motors at the same time. They drive out of phase, so one starts at tick time of 0, a milli time of 0, and the other starts at a time of tick time millis over 2. Okay, so every time the loop is come, we do a motor next step if a next step is required, and we check to see if we need to update the tick time, one for each channel. Does the same on each channel. If the tick time needs updating, it sets a number of steps for the motor to go on, always 1, and updates the tick time. So that should nicely drive both motors round. So this is still running the old code, and then you can see the LEDs are blinking around there. I haven't connected up either of the actual motors yet. We can check it's working just from the handily provided LEDs. So let's, without further ado, find my mouse pointer and fire it down. Is it doing it? It is. That seems to be working. Again, it's still going round at 1 minute per division or whatever instead of 1 hour, just so we can still reasonably check it's working. So should we plug both the motors in and see if it works? Well, it thinks it's drawing current. Okay, so I'll turn everything off and let it run for a couple of minutes and just check they're both going round. Oh, so that one's just gone up, so that side's working. This side was at 26 when we started and it's now under 25, so I'll give it another minute, and if it gets to 24 I'll say we're good. Right, now we want to be able to set up the timers to the times we want, so we need to be able to spin the knobs round at a faster speed and set them where we want them. So I've written some code to do that. Now the first thing in the setup, I've set the pin modes of the two inputs, their IO number 8 and 9, to input pull-up. So there is now an internal resistor in the Arduino processor chip which is pulling those inputs high, and the switches simply ground them. It saves having to solder a resistor somewhere to do the job. To control this, the good old mode and action model. So we've got a set mode, which is set mode off normally, and can either be set mode channel 1 or set mode channel 2 if the buttons are pressed. So we look into set mode here. If it's off, we look for channel 1 button being pressed, and if so, we set the steps to FF, which means run the motor continuously, and we set the set mode to channel 1. Similarly for channel 2, and if neither of the buttons are pressed, we just do our normal driving the motors round at the normal speed. Set mode chan 1 and set mode chan 2 are the same. When it's actually in the process of setting that channel, all it does is it checks for the button to be released, i.e. the is button pressed equals false, and if it is, it sets the motor steps to 2 and sets the set mode back to off, and is button pressed just looks at the port and returns true or false. Very simple. Okay, shall we see if it works? I know it compiles because I've checked it as usual, and I need also to move those out of the way which have annoyingly flipped up. So okay, without the button pressed, it's doing its normal thing. So should we see if we press this button what happens? Oh, it's working. It's going round. We can see that going round slowly. Now that's a bit slow. We might try and speed that up. That would be rather annoying to have to wait for that. And the other one. Yep, that's going around nicely. So let's see if we can speed that up a bit. We've set these in the code here. We should really have defines for a define for this rather than altering the numbers straight in the code. However, we will do this way for now. Right, let's put these back again. Is there any faster? Let's set them to 10. See what happens. That's better. I think we can live with that. So oh, cheapo switch. Okay, shall we just for a laugh, just for the fun of it, check the time? So what I'll do is I'll get a clock or a phone or something so we can check how good they are, and I'll set them up and turn you back on. Right, so it's now 27 minutes past according to that clock, radio control clock, so it should be right. And I am gonna set this side to 44 minutes, we're still on minutes, and this side to 'Oh, it's not that fast even now, but it's okay, it's acceptable. I'm just going to hold the camera in the other hand as well. So we'll set this side to 40 minutes, and we've just gone 28, and I'll turn the camera back on when those two are about ready to flip up. Okay, so it's 7 minutes past 1, and if we look at this, yep, any minute now it's gonna go. So more exciting video. Oh, there we go. There we go, and that is 107 and some. You see that? Yeah. So let's see when the other one goes, and then I shall have to check the accuracy when I edit the video, but it's something like. Right, so 10 past 1 on the clock, and this is almost there. Hey, and there we go. Completely obscured the clock now. Retrieve it from there. Just after 10 past 1. So, well, 10 past 1 and a half. So, we'll just check those times or something like, I'm sure they are. And the next step is to set it so these are in hours, not in minutes. And we'll try it again. So I think I'm gonna wrap it up for this video here, and next time we'll get these to run in hours, not minutes, and I'll also get into trying to shoehorn this lot into there somehow. And then it'll be done and we can move on to a fresh project. So for now, subscribe if you like the channel, leave a comment if you've got anything to say, thumbs up or thumbs down even, and for now I'll see you next time. And there he is. Great lazy lump, eating sleep. We've actually caught him awake. Trevor! Trevor! No, ignore me, as usual.